आप सभी को सप्रेम नमस्कार. Good afternoon and a warm welcome to everyone. Before I begin, let's give a loud round of applause for Ms. Monica Bachchan and her team for bringing together such an august gathering. And I stand here humbled by the presence of industry stalwarts, policymakers, wonderful technology providers. At the same time, I am proud and excited to put forth the work that our team of seasoned metallurgists have put through for preventing rejections, increasing yield, and reducing fuel consumption in hot rolling operations. A very quick introduction. The company was incorporated in 1985 by metallurgists from IIT Mumbai. Because of the metallurgy background, all our technologies are towards hot rolling, hot forging, and heat treatment only. We specialize in preventing rejections and the benefits for hot forming processes. And to solve the problems that are identified in these industries, we manufacture, with the knowledge of metallurgy, chemistry, and tribology, we manufacture customized coatings, lubricants for these processes. And by virtue of being highly customized, we are sole suppliers to industry leaders in India, Poland, Spain, USA. And I'm also proud to share a recent success. We are the only Indian organization to develop coatings for heat treatment of aerospace steel, which was used in the prestigious Chandrayaan project. To assist us, we take assistance from reputed laboratories which specialize in applied research. For example, BFI Germany is such a reputed laboratory. CCRT Laboratories is a testing lab located in Navi Mumbai. Again, metallurgical labs located in Navi Mumbai. And we have the privilege of working right from the steel making to the hot forging companies that process the steel and with the automotive companies that use the steel. Simply because all of these companies have hot forming processes. And how exactly do we help them? In these three areas: steel, fuel, and of course lubricants I'll not be discussing today. The good part is all of these technologies do not require capital investment. Whatever I'll be speaking today can be easily established, and the ROI is within 2 months or 3 months max. And I'll be putting forth case studies from wire, long products and flat products and alloy steels. To prevent rejections during hot rolling, we manufacture metallurgical coatings to control decarburization and scaling. To reduce furnace downtime and maintenance costs, we manufacture refractory coatings to increase refractory lining life and reduce fuel consumption. At every stage of heating steel, scaling is inevitable. What you're seeing on the screen on the top left is a billet that is heated and there is scale on it. Top right is an ingot heated at 1250 degrees Celsius. Prior to open die forging, you can see the scale present on it. Even if you use modern technologies like induction heating, this is an induction heated billet. However, depending on the grade of steel and metallurgical parameters, you do experience scaling. What is the worst case scenario of scaling? This is a painful picture. The hot roll product is being gas cut to be fed into scrap. This organization has taken a lot of efforts to melt steel, to hot roll it, and they are gas cutting it and scrapping it simply because there was excessive decarburization, there was excessive scaling. If you have unplanned downtime, your billets are getting excessively heated in the furnace, which leads to all these losses. Apart from direct loss like rejections, due to scaling, you have material loss, maintenance issues. The scale gets adhered to the rolls, which causes quality issues. It damages the hearth of the furnace. A lot of times, furnace downtime is taken just to remove scale from the rolling mills and the furnaces at all. Downstream processes like peeling, pickling, shot blasting, these processes do not add value to the product, but they add costs, they delay your dispatches. A quick understanding of scaling. The same oxygen that breathes life into you and me is also responsible for millions of dollars of loss on a daily basis due to scaling and decarb. Oxygen combines with metal to form metal oxide, which is nothing but scale. And the general practice in the industry is to remove the scale or the decarburized layer by expensive operations like grinding, peeling, whatever you may have. With the knowledge of metallurgy, we have fundamentally tried to curb this reaction. A simple mechanical barrier is developed. It is provided on the metal, which acts as a barrier between oxygen and metal. It does not alter your heat transfer. It does not alter your metallurgical parameters. And that's where the metallurgy comes into play. Oxygen has a high thermodynamic affinity with metal, which means the higher the temperature, the more the time, the more is the scaling and decarburization. And hence, depending on these parameters, oxidation is either prevented or delayed. It sounds a bit paradoxical. I'm either saying prevented or delayed. What I mean to say is, if the temperature is 1000 degrees or less, for example, in heat treatment operations, there are cases where we have been able to deliver zero scale loss. When it comes to 1250 degrees Celsius, there aren't many economical materials available to substantially reduce scaling. However, we have been able to reduce scale loss anywhere from 50% up to 80%, all documented. Some fundamental questions that you may ask since you're introducing a new process in your production. The coating does not react with metal. It does not emit any fumes during storage or use. It's absolutely safe. It does not alter heat transfer. Just for the use of scale preventive coatings, you need not increase your furnace temperature or your soaking period. And of course, it has to be economical. Well, just to let you all know, we are in business since 1985, so that proves that these are economical and established technologies. The method of application should be easy by brushing, dipping, or spraying. A quick picture. This is a couple of types of coatings that are given on the billet prior to charging them into the furnace. You're seeing different colors simply because we do need to carry out a few tests to ensure that the metallurgical parameters are met, and that's where the customization takes place. Coating is sprayed on the billets prior to charging into the furnace, be it long products or flat products as you're seeing. These are hot rolled sheets being spray coated prior to heat treatment, and at all stages to control scaling and decarb. A quick example of controlling decarb. What you're seeing on the screen is a billet which will be hot rolled to make rail steel. Controlling decarb on rail steel is most important simply because if you have decarb on such critical areas on which the train moves, it would lead to cracking and failure. And hence, you need to control decarb. Decarburization is a surface deterioration phenomena. We need to control it, and if your depth of decarburization is less than 0.3 mm, it can be used as steel. If it's more than 0.5 mm, it cannot be used as rail steel. It's straight away a rejection. So imagine you're heating your billets with the intention of making rail steel, and your decarburization is above 0.5 mm, you are losing the entire heat. So to control the decarb, here is the coating that is applied, and a quick cross-section view of the result. This white layer that you're seeing is the decarb, which has penetrated. Now this is a surface deterioration, and it would have to be removed before the steel can be used further. On the coated area, you can see that there is very less or negligible decarburization. And as a result of this, we've had customers who are peeling the rolled bars. They roll the steel, they peel or remove 2 mm simply to remove the decarb and the scaling. So we've had customers who have gone from 2 mm peeling to straight away to 1 mm peeling, and no capital investment, just coating the billets. No additional investment for increasing a peeling machine either. A tribute to the senior metallurgist at Vardhaman Special Steel. The gentleman has extensively used coatings at the billet stage to control decarburization, to reduce scale formation, to improve surface from micro cracks. And again, some of the hot roll products need to be heat treated. So before heat treating, the coatings are given to control decarb and various others. Various grades, ball bearing steels, 9254, spring steels, whatever you may have. some of the grades here, automotive steels, SAE 52100, 16 MN CR5. What they've mentioned here is when the coating is not used, 1% of the section is susceptible to decarb. When the coating is used, less than 0.5 and occasionally up to 0.25% of the section is decarburized. So again, like I said before, 50 to 75% reduction in scaling and decarb. This is a case study from Rourkela steel plant. Due to the presence of sticky scale, they used to carry out short blasting operation 3 times just to remove the scale and to give good surface finish. By use of coating, they were able to reduce the short blasting operation, eliminate 2 short blasting operations, and with 1 single short blasting operation, they were able to carry out the dispatches. A 66% improvement in productivity. This is a more visual appeal. These are hot rolled billets. They are spheroidized annealed prior to cold forging, and spheroidized annealing is a very long heat treatment cycle lasting for 16 to 18 hours. And what happens after such prolonged heating is what you're seeing on the screen. A lot of blemishes. In spite of short blasting, there are no scale pits here. But imagine making an automotive part using this component. I mean this billet. It would not look good. And short blasting carried out for 20 minutes. At the same time, in the same furnace, if you use the metallurgical coatings, you can see a much better surface finish here, and short blasting is reduced from 20 minutes to 12 minutes. End cuts can be reduced right from 20 end cuts to 10, simply because the surface area of edges of billets are more susceptible to scaling and decarb, and that's why wire rod manufacturers have to actually cut 20 ends to get a good surface finish. That is reduced from 20 end cuts to 10. This is a case study of nickel steel, which generates very sticky scaling. In spite of having a very good descaler, the image that you're seeing here to your left, you still have scaling on the billet after passing through descaler, because it is very sticky scale. In the same furnace, by use of coating, the same descaler at 200 or 220 bar is able to effectively remove the scaling, simply because the scaling is reduced by around 58%. And what you're seeing here is scale thickness that is measured from both the billets that I showed earlier. The not coated billet has 1.66 mm thick scale, and the coated one has 0.7 mm. You can appreciate visually also. That's again a 57% reduction in scaling. Allow me to just show one slide of commercials. We do believe that any technology that is put forth in the industry, only if it is used extensively and commercially viable, it is actually a success. What you're seeing here is the numbers of a stainless steel rolling company. They do 19,000 tons per month. They experienced scale loss of 0.46%. We were able to effectively bring it down to 0.13%. And the math works out to 1.1 crore rupees of saving per month, net saving. This is after removing the cost of application of the technology. Net saving, 1.1 crore per month, no capital investment. And that too, I'm only speaking about the material that is saved here. I'm not even considering the fuel that is saved, saving the cost of transporting the raw material, saving the cost of improved roll life by reduced scaling. All of those I'm not even considering. Just the saving of material is 1.1 crore per month. And a certificate of recognition that we have received for our work from Viraj Group. And this is how the technology is automated. I'm not sure if I can play this video. I'll be happy to share the video during open networking tea session. So these are slabs that are being hot rolled. What you will see here on the screen is, in spite of using a descaler, the sticky scale is still seen on the slab. Look at this now. Imagine making a rolled product using this. You would definitely have irregular surface finish in many cases. In this particular case, the end product is a 2 mm thin sheet, and this scale was actually causing through and through holes. And in the same organization where the slabs are coated with the customized metallurgical coating, the descaler is much more effective, and what you'll see is a good surface finish. You can appreciate it visually as well. We are glad to receive the certificate of recognition from Tata Steel for Tata Group for our work on preventing scale in various aspects. Our technical director receiving the award. We've also worked with some of the overseas reputed steel manufacturers. This is a recognition from Walson Leva, AISI 416 grade, where they were facing issues of high temperature scaling and mill skid situation. Now I quickly move on to the next subject, protective coating for reducing fuel consumption in furnace operations. What you're seeing here is a refractory lining of a furnace. Here is the coated refractory lining. The coating can withstand 1900 degrees Celsius. It reflects the heat back into the furnace, thereby reducing fuel consumption and increasing your refractory lining life. It can be done on a used refractory also, as you see here. Okay. So just a couple of quick case studies here. The furnace outer shell temperature, furnace temperature is 1250 degrees Celsius, and this is at Jindal Stainless Hisar. The return on investment, 1 month. Umpteen such case studies. This one is from Mahindra & Mahindra. A recommendation from Tata Steel stating that the average fuel consumption per ton reduced from 18 to 19 liters per ton to 16 to 16.5 liters per ton, and faster heat up time of the furnace. I believe I've overshot my time, so thank you so much for your patience, and I'm open to discussions, questions whatsoever. Thank you so much. Thank you.